Okay, let's start a new circuit, and I think this is gonna be our 14th circuit. Okay, on our last video, we discussed about the integrated circuit, and we particularly used this timer, uh, which allows us to control pulses. Another integrated circuit that is often used by hobbyists in electronics and those learning electronics is the decade counter. So let me see if decade counter. There you go. So this is a decade counter. It's another integrated circuit, um, and what this one does is it also um, controls pulses, but it's called a decade counter because it pulses and counts up to 10 and then it'll restart. Okay, so we're gonna use this timer integrated circuit and this decade counter to create what we call a lead chaser. So if you try to Google a lead chaser circuit, chaser circuit is a circuit that uses the timer, okay, and the decade counter. And what it does is it sends out power at a high level to each one of these pins, and it has 10 output pins. And when it does send power to one of the pins, if you connect an LED on the end of it, it'll light up, and then it will go dark and it will light up the next one, and it can light up to 10 bulbs, one right after the other. So we're gonna sort of do this kind of circuit. It's called a lead chaser, and so let's go back to Tinkercad, and we're gonna use this timer and the decade counter. We first need a battery, and so let's try this battery now. So we're gonna drag that. Now this is only a 1.5 battery, but we could always switch it, change it to like 2 batteries or 3 batteries. And I think uh, 3 AA battery is good enough. We're gonna just rotate this. Okay, put that closer here. Maybe here, yeah, just there. And then let's put that in a corner. Oh, zoom. Oh, there you go. Let's zoom, put that in the corner. And let's start this circuit. We also will need, I think from this diagram, we're gonna need 2 capacitors. So this is a symbol for a capacitor, this is a symbol for battery. These are resistors, okay? And each one before the lid will have a resistor. So we're just gonna copy a capacitor and resistor. I think we're gonna skip this LED here, LED. We're just gonna do these 10 LEDs that would output. So we will need a capacitor. Okay, so capacitor. We're gonna need a capacitor. Where should we put this? Maybe just here. Maybe just here. Okay, so just a capacitor over here, and we'll need the resistor. Oh, no, I don't want that. Okay, resistor. Just we'll just copy this resistor later. Okay. We're gonna need several of those. We also will need an LED. Okay, so put this LED. I think somewhere here is fine. Somewhere here is fine. There you go. Okay. All right. So why did this rotate? Well, I can rotate it. So I just want it upright. Okay. So let's start with this one. I know that the positive red. By the way, it's a reverse on a 9 volt battery. I mean the position. So the positive is always red, and I know that this pin over here is the power, and the positive should always go here. Okay, so maybe should just first connect that, connect here, and then bring that like that. Now the reason why I want this angled is because let's change it to red. I'm gonna need to provide several power to some of these pins over here. Okay, so I know that there's also a power here that I'm supposed to connect together. So I'm just gonna grab a connection from here. I know I'm gonna do a lot of power, so I'm gonna click this power and connect this to uh, maybe provide a connection here like this. So let's just sneak. There you go. And then I know I'm supposed to provide power to this capacitor. Let's try to check our. So the capacitor has a resistor. It's a variable resistor actually, but let's just use a resistor here. Control C, Control V, and then I can connect that directly there, but I just want to show you that we're supposed to have a wire. So I'm gonna connect a wire to that one. Okay, so I changed my color red so I don't change it again. And I know that I'm supposed to get an output somewhere. I think the output is going to be here. The discharge is going to discharge and provide power here. So I'm going to just get this discharge and provide power maybe here to this resistor. Okay, and then this will be the negative terminal that's supposed to connect over here. The negative is also supposed to be your ground, so negative and ground are roughly the same. So let me just connect that one, and make it grounds are black, so change that to black. Okay, and then this one is also a ground, and since we have a connection here, I'm gonna just connect this and that one. Okay, let's see, maybe we need to arrange this and move it a little bit because we're gonna have multiple connections. Okay, so here it's gonna go here. The, actually, I can cross there, but yeah. Okay, so and then just black. Okay, so it provides there, and then I'm supposed to also provide a ground. Where would I put the ground one? 1, 2, 3, 4. Inverted output, I believe. Okay, inverted output. Clock enable, I think. I think it's this one. So let's check, and we can verify that one later. So where would I go? I can just go straight here, and then go and connect a black line to clock enable. There you go. And then I should really go here to the ground, but I need to connect those. So let's connect them now. I can go here directly, but I can just do this instead. And connect that, and then let's just add something here. Okay, and that's gonna be black. Okay. All right. And And then I know I'm supposed to connect the power and this discharge um, by putting first a resistor. So let me copy this. I hate this, so let me just close this and copy this, Control C, Control V, and then just rotate that first. I'm sorry. Um, and then put that here, like so. And then I'm going to connect this line, which is a red, and then I'm going to connect that to the second one over here. Thing is, I'm going to have, let's just move this. I'm not a fan of, and a connection here, 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 then go. All right, so oh, no, this one is connected. No, this one is connected to here. That one. So this one is connected to the second terminal over here. Okay, and then this one's connected. I think that's it. I just know. Okay, so now I think that's the connections. Let me see. Two connections. There's a connection here, a connection there. Okay, so let's. Okay, so we need to also connect. Maybe we can just use this resistor. I'm gonna connect um, the trigger to this resistor, and I'll just change that to orange. Okay, and then I need to connect this trigger with this threshold, so it triggers it after it receives the pulse. So sometimes there would be no option no option for you, and you will have to crisscross wires, and because it's just, and let's just add to orange also. Okay, so I know I'm supposed to, we're missing reset. Okay, so let's connect the power and the reset, so we can control the no, I'm gonna have to like crisscross somewhere here. Then, okay, all right, let's look at our threshold Q, and threshold here, ground 2. Okay, I think we're good. Okay, so power here, and then connect that, and goes to the resistor, the capacitor, positive, goes here, connects, and goes connects here, and then this one's connected. Okay, I know I'm not going to use the voltage control, it's a different circuit, but I know that the output here will have to trigger this. So where would we connect this? To the clock. Yeah, it triggers the clock. So sorry. Let us make a connection to the clock. Yeah, there you go. Okay, let's change that to pink. Pink. Yeah, connection to pink. Okay, red to orange, and then connects here, connects there, connects to here. And this was connected there. I think we're good. We're not gonna use the reset because it'll not stop. We're gonna use the whole 10. If we only have like, 8 leads later, we have to use the reset, and then on the night we have to short that. So anyway, we're going to use all 10, so we're not going to use the reset. And so all of these now are going to be used, the outputs. Okay, so you can see they're all outputs. And there's 10 outputs. That's why it's called a decade counter, because it sends 10 power signals to that one. And so I think we're good with that one. So let's make 10 of these. Let's make 10 of these. So Control C, Control V, put that there. Control V, put that there. So it's 3. Okay. Shift and then make a window. Control C, Control V, so I can copy 3 at a time. Okay, and then Control V again. So that's gonna be 9. And Control V. We're over, so I'm gonna just delete these 2 and put the 10th here. Okay, so 3, 6, 9, okay, 10. And then these negatives are going to be all connected to each other and connected to this negative power. Negative here connects here, connects to this ground over here, and then connects to this one. So we're going to make those connections. So let's first connect this one to this one, negative lead, okay, and red or black. So for negative, I'm going to just choose black here because I'm going to connect this leg with that leg and all the straight legs. So connect this like that. Okay, and this, that one. Oh, I didn't catch that. That one, that one. So they're all connected together. If we were using a breadboard, then these legs would just be connected to the black line on a breadboard, to the black row or black column. Okay, and then I know that if you look at this one before the LED, so they're all connected here, but the positive terminal has a resistor for each one. So we're going to need to put in resistors. So I think I'm going to use this resistor and put it here, and then this will be a red connection. There you go. Okay, then Control C, Control V. So we need 10 of these. I should have copied this also. Now these resistors would have to control the current that goes into the LEDs, and too much current will shorten the lifespan of the LED. Just like any light bulb, it'll burn out if there's too much power. And so, see, I want to do a red connection. So here to there, here to there. Okay, here you go. So each one has a connection to that one, and then each end of that resistor is connected to all these outputs. Okay, so we're going to do an output here. So if you wanted, so how I remember this decade counter is it doesn't send its output on the first, but it sends its output on the second. So well, I'll let you see. So this is our first bulb, and output number 1 is this one. But when we run this later, the second bulb we will run first. I just don't know why it does it that way, but let's just follow the output. So 1 to the first bulb. So output 1 to this one. Okay, do that. Do this. Okay, now technically that's power, but just so that we know that it's an output, let's just change it to, let's try blue. All right, so blue. So let's do blue. So first output to the first bulb powers the first bulb. Second output powers the second bulb. Okay, so second output powers the second. Okay, and then there you go. Too far. Let's just put that up here. Okay, and the third bulb is output number 3. There we go. So 3 to this one. There you go. And then 4 is number 4. Oh, 4 is over here. Okay, so 4 to this one. So I don't know really why they're not in order. You know, it doesn't go 1 2 3 4. It doesn't go 1 2 3 4. Just it, because inside here it has its own circuit like this, and it's just miniature. So they need to put where they need to put it doesn't touch each other. So I guess that's how they go. So we're now in number 5. So 1 2 3 4 5. So power 5. Where's 5? 9. Oh, there you go. 5 is out here, huh? Let's see. Well, we could too much here. Maybe we just go here. Go all the way around. Output to 5, but we want to go output to 5. Maybe. Okay, so just to make it neat and clean, turn that. Just move this a little bit. There you go. And then 6 now. No, 6 was here, right? 6 is also, where's 6? Now 6 is here. Okay, 6 will be here. Connection here. And then connection here. Bring this up. Okay. 7 is here. Oh, 7. 7 did that one. Just straight. 7. And then 8. 8 now. 8 go here. Okay. I know 9 is up here. 9 is this one. So we go 9, go here, go here, go here, 9, and the last one, 10. 10 would be here. Okay. 2, 3. We're not going to use this inverted output, and we're not going to do a reset so it doesn't, because we're using all of the outputs. Okay, what else did I forget? Here, capacitor goes here, and then goes, we're going to use a common resistor before it goes to the capacitor and before it goes over here. You can connect this, but it doesn't matter. Okay. We can put a built-in switch on the battery. We just use yes. So we're gonna there's a switch now here, and we can run the simulation. It's an off. So when you turn on, oh, it doesn't work. Ah, I know what I did wrong. Okay, so it turns on. I need to adjust some of the um, settings for, let's say, this capacitor. What is the setting on this capacitor? It's only 1 microfarad, so I think I need to make that 100. I think this one is resistors is just one, okay, but resistors, yeah, 1000, 1000. So here, the brighter you if you want a brighter LED, it says 150. I don't know if that's good for us for a 150. Let's see, what's this one? Let's make it. Let's see it to one first. Let's check one. Let's start simulation, and then so let's see, it's now working. So one bulb is lighting one after the other, and we can make the bulbs brighter by reducing the resistance, more power. So let's do half, 0.5. Okay, you see this one brighter than the rest. Let's make this 0.5. 0.5. Because if you make that 2, it'll be go dim. So here, it should go dim here. Yeah, because it's brighter. So 0.5, 0.5. I don't know if see that this one, if I made this 0 and there's too much power, I guess what's gonna happen is, so it's, you see there's a explosion here. It's because this one has an error on it. See, because I only put in 0.5, and while I'm changing it, it'll mess up the board because there's too much power on that one. It's basically 0. Okay, stop and start. Okay, and goes and counts 1, 2. Turn it off. Let's see. Will the first bulb light up and turn it on? Oh, this is a CMOS, which CMOS is it remembers its setting. So we have to stop simulation, turn it off, turn it on, want it off, stop simulation. Okay, it's automatically turning on by itself. Anyway, I think, and then you can also change this light bulb to a different color. Green for that one. You can also change it to blue. You can change it to different colors, white. If you want it like that, it's up to you with however you want to do it. Okay, but that's what we call a LED chaser diagram. It uses a timer. I think if I adjust the capacitance, I would have faster. So if I adjust this to, let's say, 50, would it change it? Enter, start, stop. You think it's faster? Yeah, it's faster now. So because you lower the you lower the capacitance, you let more power on here. So if we make it even lower at 20 and then start, stop, it should become faster after. Yeah, there you go. It's faster. So if you change the capacitance, if you want it lower, you have to increase the power here. Okay, And so that's it. This is your lead chaser diagram. Make one yourself. You can change different colors here. You can adjust how fast you want it to be. If you make it 200, it'll become really slow. So let's turn it off and turn it on. Oh, what happened? What did I do? 200. Yeah. Stop simulation. There you go. Make it even. Stop simulation. Make it 300 or 400. Should really be slow. See how slow that is? Okay. And then if you make it lower, it'll go faster. Okay. There you go. This is your lead chaser. Sorry. Uses a timer and a decade counter. So make one yourself and choose any color that you want. Okay, begin.